Thank you, Katie. In recent decades, the development of coastlines and new innovative technologies have increased the anthropogenic activities in our oceans, ranging from marine traffic to coastal development to sonar and seismic activities, all of which can influence the behavior of cetaceans. Hello everyone, my name is Evenepoel and I'm going to tell you how marine traffic is impacting the behavioral budget of bottlenose dolphins in the Gulf of Antalya, Turkey. So previous studies have been done on this subject where they investigate also the impact of marine traffic on the behavior of cetaceans. They are mostly tourism related, so whale watching and dolphin watching. And they also mostly target bottlenose dolphins, but other cetaceans such as the fin whale, beluga whale, Indo-Pacific humpback dolphin, dusky dolphin, Hector's dolphin, common dolphin have also been assessed. So due to the unregulated and uncontrolled human pressures we see in the Mediterranean that the vulnerable bottlenose populations are declining, and these can all influence the short-term behavior of the species. These short-term behavior alterations can manifest as modified vocalizations, horizontal and vertical avoiding behavior, the increase in swimming speed, decrease in time spent foraging and resting, and habitat alterations. Now, these alterations can have long-term effects on their behavior by reducing the survival and reproduction of the species, which then eventually leads to a decline in population size. So the effects of marine traffic are actually really poorly understood. That's why it's so important that more studies should be done about this topic. We are also the first study that investigates the impact of marine traffic on the bottlenose dolphin, on the behavior of bottlenose dolphins in the Gulf of Antalya in Turkey. We chose a spot because the Gulf of Antalya is actually known as a hotspot for bottlenose dolphins. And also previous studies have investigated this and saw that it's actually a kind of a critical habitat. That's why we hope that this study will aid decision makers to the establishment of management and conservation strategies to help minimize the decline of the already threatened populations in Turkey. So the study area is located in the northern part of the eastern Mediterranean Sea. It has, as I just said, it is identified as a critical habitat for bottlenose dolphins. It has an area coverage of 2,002.3 square kilometers, and as you can see in the figure, can reach depth up to 2,000 meters. So data is collected by the DMAT research team in Turkey between March 2015 and January 2020. They collected both and behavioral data, and the behavioral data is collected through vocal group scan sampling. And they did this by doing land and boat surveys. So during land surveys, they used a theodolite, which you can see on the figure, by the way, the horizontal and vertical angles of both marine vessels and groups of dolphins. And these were later transferred into Pythagoras to geographical coordinates. Well, if we did both surveys, it was really important that we kept to certain rules to approaching dolphin groups. So if a group was spotted, then the boat would approach the side or the rear of the dolphin group and approach in an idle or very slow speed, and would keep a distance between 50 and 400 meters. If the dolphin group moved to the boat, so actually approached the boat, within 50 meters, the boat would stop and remain idle. While if the dolphins would actively move away from the boat, the pursuit was stopped, and to further reduce negative impacts on the species. So it's also really important that if we define dolphin groups, that we say what when marine vessels are absent or present. So we have this 400-meter impact zone, and when the marine vessel is outside of this 400-meter impact zone, we say that the vessel is absent. While if it moves within this 400-meter impact zone, we can say that this vessel is present. This is also what we later use as control and impact situation. So the control is when vessels are absent, so outside of this 400-meter impact zone, while the impact situation is when vessels are present and thus within this 400-meter impact zone. So for the data analysis, we investigated two important aspects: the behavioral transitions and behavioral budget. For preparing, before we could analyze behavioral transitions, we had to prepare our raw data, and we used a conservative approach with 4 important rules. Then we were able to use Markov Chain. Markov Chain is a very commonly used method to assess the one-way dependence of a behavioral state to the preceding behavioral state. This dependence can be affected by any potential factor between these events, and hereby we were able to calculate the probability that a group of dolphins would move from one behavioral state to another. Monte Carlo simulations were then later used to estimate the behavioral budget of the bottlenose dolphins. These were based on the behavioral transitions we calculated with Markov Chain, and we set our simulation duration time for 24 hours. So then the results we saw that for transition probabilities, that remaining in a feeding state, so from going from feeding to feeding, decreased with 20.3% in impact situations, so when vessels are present, while feeding to diving increased with 14.6% also in impact situations. For the other probabilities, we control an impact situation. So as we can see in this figure, on the left we have the control situation, so when vessels are absent. And if we then look at the impact situation, we can see that from feeding to diving, it increases, while remaining in the feeding state almost reduced with half. Then we had an exposure level to marine traffic of 33%, which means that marine vessels were 33% of the bottlenose dolphins their time. Okay, that doesn't make any sense. Bottlenose dolphins spent 33% of their time in the presence of marine traffic. And although this happened, we didn't saw any change, any considerable change between the control and impact situation. In the figure below, we have a blue line and a green striped line. The blue line represents the control situation, while the green striped line represents the impact situation, and it only increases slightly and decreases slightly in feeding and socializing. So we couldn't actually say that there was a considerable change. Okay, for the discussion, we saw, as I just said, that remaining in a feeding state decreased with 20.3% in impact situations. Feeding is an essential part of a dolphin's behavior. And even though dolphins are able to modify their behavior for the occasional presence of vessels, repeated interactions in the area will result in the species not able to modify their behavior anymore, which eventually could lead to long-term negative consequences. The decrease in energy intake is another threat on the long list of threats for this species. We saw in our study that 34% of all marine traffic in the Gulf of Antalya are fishery-related vessels. And we know that fishing vessels in the Mediterranean and thus Turkey are already depleting the food source for dolphins. Additionally, we saw that vessels cause an extra decrease in energy intake, as has been supported by this study. So if the energy intake does not compensate the energy expenditure, we see that there is a negative energy balance, which could result in weight loss and eventually starvation and death. So from feeding to diving, we saw an increase of 14.6%. It has been suggested that the increase in diving, or that diving is actually associated with feeding. Because, yeah, dolphins are evolved to spend longer times underwater for foraging. However, there's little known about the diving behavior of bottlenose dolphins. So, and other studies also suggested that it could be some form of vertical avoiding behavior, which means that dolphins would spend longer times underwater to avoid vessels because they perceive them as risks. We suggest in this study, our behavior suggests that it's more or less likely that the bottlenose dolphins in the Gulf of Antalya are showing this vertical avoiding behavior at the cost of other critical behaviors such as feeding. Well, if this hypothesis is proved to be correct, it could lead to health issues. And diving also requires a lot of energy, and if this is not compensated with extra energy intake and thus feeding more, it will create an imbalance in the energy homeostasis. Also, avoiding vessels is very stressful, and stress has been known to reduce the immune system and thus make the animals more susceptible for various kinds of diseases. Although we didn't saw any change in behavioral budget, and although they spent 33% of their time with marine traffic, we saw that some studies actually did have considerable changes in their budget with even higher and lower exposure levels than our current study. However, most of these studies are tourism related. There's only one exception of a study of Baz et al. Of 2017, who focuses on the overall effect of marine traffic in the Istanbul Strait, also on the behavior of bottlenose dolphins. So we can, in the Gulf of Antalya, because dolphins are not actively targeted by tourism, that's probably the reason why we don't see a change in the behavioral budget yet. So the results. Okay, so sorry. The results are concerning, however, not yet alarming. We saw that dolphins are affected by marine traffic, and that's kind of, that's not good, that we don't want that. That's why management and conservation action should be taken now in order to protect them, because like in Turkey, there are no such plans yet to protect bottlenose dolphins, although they're threatened by overfishing, bycatch, and habitat destruction. That's also why more future research should be done, and they should investigate if the presence of vessels alters the bout duration of the species. Moreover, they also should investigate if the speed, the vessel type, and the distance of vessels alters the proximity, that the proximity of vessels alters the behavior of bottlenose dolphins. And all this research could contribute to proving the hypothesis of the form avoiding strategy and at baseline knowledge, general baseline knowledge. Like first, I want to thank all the volunteers and interns of DMAT, Marine Mammal Research Association, for their support and data collection. And we would also like to thank Freeport Small Grant Foundation and WWF Turkey for their financial support. Also, personally, I really want to thank all the interns that supported me by making during my thesis, and also really my supervisor, who was always there for me and helped me make this thesis possible. Thank you all for listening.